Welcome back. This is Unit 13, Lesson 2. We just finished example number 3 and 4, and we are on to example number 5. It says given circle A. So right away, what do you know? A is the center. It tells you so much. You know about radii, you know about diameters. It gives you a lot. It says find the area of the shaded region to the nearest hundredth. So that means that we're going to put pi into the calculator. It says if the measure of angle B see, there's that letter A. A is the center of the circle. That means this is a central angle, which means it's equal to its intercepted arc. So if the angle is 62, the arc is also 62 degrees. So they want us to find the area. So the formula is always going to be central angle, the fractional part out of 360. But they just want this shaded region here. So what we're going to have to do is take the area of the big circle. All right, so we're going to take the area of the big circle and we're going to subtract out the area of the smaller circle. And that's going to leave us with the area of the shaded region. So just like all the other problems that we've done in the past. All right, so once again, we're going to start with that central angle over 360 times the area of a circle, pi r squared. We're going to do the same formula for the small circle, but using the radius of that circle, and that's going to give us the area of the shaded region. So the central angle is 62 degrees divided by 360 degrees. Now we're going to multiply that by pi. Now what's the length of the radius of the big circle? It's from A all the way to C. So it's going to be the 6 plus 2, which is 8 centimeters. So we're going to take that 8 squared. So when I put that into the calculator, that gave me an answer of 34.62733236. And I'm not going to round until the very end. Now we're going to do the same thing for the smaller circle. The central angle is still 62 degrees out of 360, but this time the smaller circle has a radius of only 6 centimeters. So we're going to do pi times 6 squared. And this time I got an answer of 19.477874445. And now we're going to subtract those two and get us the area of the shaded region. So I put in our 34.6273336 minus 19.477874445, and I get an answer of 15.149. I'm rounding to this is the 10th, this is the 100th. So since the next number after the 4 is greater than 4, that 4 becomes a 5. So our area of the shaded region becomes 15.15. And if you want to get fancy, you can put the unit of measure, centimeters squared, and that's equal to the area of our shaded region. Excellent job. I will see you on the next page. And guess what? Maybe you could try it out and then replay the video and see how you did. All right, here's example number 6. It says in the diagram below, the circle has a radius of 25 inches. So remember, any radii of the same circle is also going to be 25 inches. And while we're here, let's talk about the diameter is always 2 times the radius. So our diameter will be 50 inches. The area of the unshaded sector is 500 pi inches squared. Determine and state the degree measure of angle Q, which is the central angle of the shaded sector. All right, so what do we have? We have the area of the unshaded region. So let's start with a formula that we're familiar with. The area of the unshaded region is going to be equal to the central angle divided by 360 times pi r squared. So what do we have? We have the area of the unshaded region. That's 500 pi. That's equal to the central angle, which I don't have the central angle of this unshaded region, so I'm going to call that x, divided by 360, and that gets multiplied by pi times the radius, which they told me is 25, squared. So if I was to rewrite this, this is actually 500 pi over 1, right? I'm going to put this side over 1. I'm going to make everything into a fraction, is equal to Now this is actually pi times 25 squared. Hold on, the squared is not on the outside. Only the 25 is being squared. It's actually x times pi times 25 squared over 360. Okay, so these two formulas right here say exactly the same thing, but now I'm much more comfortable with this because from here I am going to cross multiply because that's going to get rid of my fractions. And even though fractions are friendly, I like working without fractions. So I'm going to take the 500 times 360. There's so many different ways you could do this. All right, that gives me 180,000 pi, right? I multiplied 500 pi times 360. The two numbers multiplied give me 180,000. That's multiplied by pi. And then the other side of the equation is being multiplied by 1. So I'm going to take the 25, square it, and that gives me 625 times pi times x. So now I'm very comfortable with this equation. I'm solving for x. So the opposite of multiplying by 625 pi is to divide by 625 pi. And look what happens. Pi is on both sides of the equation, so that cancels. So I'm going to take my 180,000 and I'm going to divide that by 625. And that gives me an answer of 288 is equal to x. It's 288 degrees. The distance from here all the way around here, this angle is 288 degrees. So now they want me to find angle Q. Well, that's super duper easy. There's 360 degrees in a full circle. I've used up 288 degrees. And the last time I checked, 360 minus 288 gives me 72 degrees. And that's equal to angle Q. Started out kind of complicated, but it actually turned out to be pretty simple. Example number 7, and then we are done. Then you guys get to do an independent practice and move on to the next lesson. So here it says, Cerise waters her lawn with a sprinkler that sprays water in a circular pattern at a distance of 15 feet from the sprinkler. The sprinkler head rotates through an angle of 300 degrees. So that means the distance from here to here is going to be 300 degrees, as shown by the shaded area in the accompanying diagram. What is the area of the lawn to the nearest square foot, that means put pi in your calculator, that receives water from the sprinkler? So again, we're talking about the area of this sector. So we're going to start with the area of a sector formula, which is the fractional part of the circle, so how many degrees out of 360, times the area of a circle formula. So the area is going to be 300 degrees out of 360 times pi times the radius of 15 squared. And look at what we got. I did 300 divided by 360. I got an answer. Then I took that answer and multiplied it by pi times 15 squared. So the area is going to be equal to 589.04. I'm actually rounding to the nearest foot, so I'm actually rounding to this 9. Since the next number is less than 4, or less than 5, I should say, my final answer is 589. And if you want to get real fancy, there's a unit of measure, feet squared. You guys are doing such a wonderful job. Here's your independent practice. I actually am going to give you a little bit of a hint on this one. Given circle O, so remember O is going to be the center. It's not labeled here, so you might want to put that into your picture. It said it has a radius of 36 centimeters, so you might want to draw in a radius, the distance from the center of the circle to any point on the circle. Okay? And the measure of angle ABC, which is this inscribed angle, is 60 degrees. Well, what do you know? The inscribed angle is half of the intercepted arc. So therefore, the arc is going to be twice the measure of that angle. So the arc AC is equal to 120 degrees. Determine the measure of the following. The measure of angle AOC, okay, central angle is equal to the arc. Then you're going to find the arc length in terms of pi. So go back to that central angle divided by 360 times the circumference. And then area of the sector is the formula right here, the fractional part of the circle times the area. Keep up the great work. Keep trying your hardest. We miss you so much. Have a wonderful day. We'll see you on the next lesson.